Okay, quadratics number 8. What are we talking about today? We're still doing the basics of graphing, and we're going to do graphing light, as in we're going to use the apps on our phone, we're going to use Desmos, and we're going to go back and look at graphing the generic form of the quadratic, but this time we're going to add in the a. So our prior graphing, we dropped the a out of the generic. Here's the generic. Ax squared plus bx plus c, and we're going to need an equals 0 in this because we're graphing the quadratic. Why is it a quadratic? Because it's got the power 2 here. Everybody say quadratic. Hold up your number of fingers, that quadratic. Interesting, interesting. I see this for most of you. Why did you do this? I know why. Tell me why. Oh, I think it's because it's to the power 2. Right? I mean, that's the challenge with quadratics. It means something with a variable raised to the power 2, basically speaking. It's the 4 steps that produce it, right? So you could have held up this or this, and I think both of them are justified in what you're holding up. And our brains are thinking different things. Was that where you were thinking, or? Okay, I'll take you up on that. That's totally logical. Okay, what's the A, B, and C in this case? These are numbers or coefficients. Everybody say coefficient. A coefficient, which I think I'm spelling it right, is a number in front of a variable. This one here is a constant because there's no variable there. So that one's actually not a coefficient. A and B are coefficients, C is a constant. Those are just the vocabulary names for those for what we're talking about in those positions. All right, let's start with the first. Let's go for our first parabola. And say parabola. All right, this is saying it wrong, but this is how you spell it. Say bola. That's how you spell it. P-A-R-A, para, and bola, B-O-L-A. But you're going to say parabola. You're going to smooth it all together, right? Don't say parabola. Your next teacher will be like, what did your last teacher teach you, right? But that is how you spell it, and my brain always does parabola because I can't spell very well and I need that help. All right, let's look at the first one here. I can enlarge it. X squared plus 7x plus 3, is it? 2x squared plus 7x plus 3. Let's do that one. Oh, I wish I could write them all down together. And let's just do 2. 20x squared minus 21x minus 5. We're not going to focus on the factoring right now. We're going to go straight for the factor. So here's your trinomial. Why is it trinomial? 1, 2, 3. We're going to factor it. Who's got their app out? Will you type this in or take a picture of it? Natalie, can you do yours? So we can go back through those prior lessons. We look at finding the factors of the tail, the factors of the lead coefficient here, and then we find out what adds up to be the center term. But let's go a little bit quicker because I want to focus on the big picture graphing of it. You ready? Take a picture of this one. Can you do it from there? And do you guys have these math apps on your phone? If you have room, download them. Please use them. It gives you not only the summary answers, so here's the factoring. Does that say x plus 3, 2x plus 1? Is that what it says? X plus 3, 2x plus 1. Okay, so how would we get back to that? Do FOIL quickly in our minds. You ready? First, x times 2x is 2x squared. So check and check. The tail terms, the last. 3 times 1 is 3, check. The question is, do we multiply the outside and the inside, combine them like terms to get this? 7x. So x on the outside, 6x on the inside, 6x plus 1x is 7x. So yes, we can quickly FOIL that in our mind and see that that is the factoring of the trinomial. Morning. Okay, now let's do the 0 property. So this has to be equal to 0 to graph. This is equal to 0 to graph. And so we're going to take the x plus 3. We're going to put it equal to 0, subtract 3 from both sides, and we get x equals minus 3. What are the names for what we're finding here? Do you know these yet? What are the names for this, what we just found? There's 3 names. They all mean the same thing. Do you know any? Do you know any? Louder? Well, so if you go through the vocabulary, right? I think we've got it. Oh, it's getting cut off right here. Here they are right here. So x-intercept, that's one name, right? Zeros, that's another name. And roots, 3 things. Can you remember those 3? So this is one of the zeros. Why is it called a 0? Because we place that term equal to 0 and solve for x to find out where this crosses the x-axis. So it's also called an x-intercept, and it's also called a root. What's the second one here? We're going to put 2x plus 1 equal to 0. Subtract the 1 from both sides, and now 2x equals minus 1. Divide both sides by 2. We now have a 2-step equation to solve, and x equals a minus 1/2. So we have 2 roots here, a negative 3 and a negative 1/2. So if I'm going to graph this, let's see how I did it over there. Let's go like this, and I should have left more room. Let's go like this. Let's put in the minus 1/2 right here. Let's go to minus 3 and stretch over the scale a little bit to here. We're putting points because this is where the shape of the graph of a quadratic crosses the x-axis. What's the name of this shape? It's on the board. What's the name of this shape? What's the name of the shape that we get when we graph a quadratic? So this is the name of the shape right here. Okay, everybody say parabola again. You with me? So strange name, strange shape, I guess. And this is what is produced every time we graph this quadratic, right? We get this type of shape. Now, do you see how this is positive up front? So is our parabola opening up or down? This is positive. For a positive quadratic where that lead coefficient is positive, our parabola is going to open up for us. Okay, so let's see what other numbers we can find. If we were to plug in a 0 for the x, where is the x 0? It's right here on the y-axis. This term would disappear and this term would disappear. We'd be left with 3. So our y-intercept right here is equal to 3. Let's put that in somewhere here. Y equal to 3. And then from our graphing app, let's find out what the vertex is. What's the vertex say for this one? So look at your graph. Does it say vertex? Look, they call them roots. Go back to the graph. Remember how last time we clicked right at the transition? Good. And does it give us that location now for vertex? Vertical. It's going to be somewhere. There you go. There you go. So this one's kind of messy. 7/4, 25/8. 7/4, comma, 25/8. And are there some negatives in there, I hope? Can't see it all. Yeah, both are negative. Thank you. Both are negative here and here. Their negatives are very small, just like I made mine. Right, so 7/4, this goes into this 1 3/4. So 1 3/4 back is here, and then we drop straight down to 25/8. 25/8 is down 3 1/8 here, coming across to form the vertex. So write vertex down here. And let's go ahead and connect the dots. It goes like this. This one comes up this way. And so there's our shape, the parabola. What's the point of this lesson? It's a big picture graphing lesson, understanding the idea of the zeros again. Prior to this, we had simple one-step equations to solve for x equal to its first root. Now we have a two-step equation here, and we'll go and do this one. Both of these binomials will produce a two-step equation. Okay, go to this one. Scan this one, Natalie. Let's graph this one quickly before I get cut off by the announcements. Okay, give me this one. Does that say 5x plus 1 and 4x minus 5? Okay, good. So let's put these, this has got to be equal to a 0, and this has got to be equal to 0 for us to then say this is equal to a 0, 5x plus 1 equals 0, subtract 1 from both sides, 5x equals minus 1, divide by 5, x equals minus 1/5. This one's going to be 4x minus 5 equals 0, plus 5 plus 5. 4x equals 5, divide both sides by 4, and x equals 5/4. What are these 2 points called? What are these 2 points called? Good. Which intercepts? Careful. Just the x-intercepts. Okay? Everybody say x-intercepts. And how do you know? Because it says an x value. It says x equals this number, so it's on the x-axis. Does that make sense? The y will have to say y equals for it to be on the y-axis, and thank you for that. Okay, is there another name for x-intercepts? I see you shaking yeses. Can you help me out with one of them? Veer, what's another name for the x-intercepts?
Don't put me on the spot like that.
You can say pass.
Oh, pass.
Really?
Yeah. Sorry, I missed it.
Is there? You panicked right there, huh?
Yeah.
Okay. You guys can always say pass. And you can always say I don't know yet, right? Please say the yet though. Say I don't know yet.
Oh, 0?
Yeah. And they're plural because there's more than one. Say zeros. Right? Everybody say zeros. And it's zeros because they're being placed equal to 0. Does that make sense? I mean, a little bit of sense. Does it make a little bit of sense? Okay. What's another name for it? Mary?
Roots.
Roots. Right? Everybody say roots. So at least from this general lesson, you want to pick up certain things. One, after you factor it, you're placing these equal to 0 to find them. That's an important part of the lesson. So as you're doing whatever work you're doing, that's something you need to practice. The second thing is coming up with the idea that they have very strange names, right? I guess x-intercepts is not too bad, but roots and zeros a little bit more and less. Zeros pretty good, but roots the least of all, right? So as we graph these, this one is x equals to 5/4. That's 1 1/4. And this is a negative value of negative 1/5. So let's try to graph here and squeeze this in. If this is negative 1/5, and it's on the x-axis, right? This is the x-axis, this is the y. This one is 1 and 1/4, so somewhere over here. And we've got points on both because that's where it's crossing the x-axis. We're intercepting it, right? Very, what's another name for these points?
It's up there.
I know. I want you to say it now.
Oh,
I'm trying to.
zeros or
Nice. Does it help you to recover? Like when you have an anxiety moment, does it help you to recover if you go back and then correct it, or no? Kinda. Okay, kinda. All right, nice. Well, I appreciate you doing that. Thank you, thank you. Okay, how about our end? Did you click? Thank you. Look at that. Look how messy that is. Let's just do the generic on this one. Let's find out where it crosses the y. If x were 0, right? So you're on the y-axis. What's the value of x? 0. If this were 0 and this were 0, you'd have a -5. Somewhere right here. -5 is where y equals because that's where it's crossing the y-axis. So this is a y-intercept. So something like this. So probably 2 big points, 2 takeaways from this. First, make sure that you're thinking about these ideas of placing these equal to 0 because this A term must be 0 and or this B must be 0 for the whole thing to equal 0. That's why we're placing them equal to 0. And number 2, the 3 names, right? X-intercepts here, roots, or zeros, those 3 names, right? Who knows all 3 names? Yep, that's what I'm going for. See? See, there's some pressure involved, right? There's some uncomfortableness, but then now you're down the road from the uncomfortableness, right? I don't know if we as humans can learn without some sort of uncomfortableness, right? There's an old saying that, do you feel uncomfortable? It means you're about to learn something, right? But I agree with you, very uncomfortable feeling, not a fun feeling sometimes, okay? So embracing that is part of the challenge. Okay, that's good.